now that we know what a polynomial is, we are going to go ahead and practice graphing some polynomials. So if we take a look at what we are given here, we are given f of x equals x to the fourth minus 5x to the third plus 5x to the second plus 5x minus 6. First thing we need to do is identify what degree it is and give it a name. So since this is already in descending order by degree, or remember our exponents, we can actually identify the degree. Since it says x to the fourth, that means that it has a degree of 4. And if we remember, anytime that we have a degree of 4, we call it a quartic. So the first name that this guy has is quartic. Now we count the number of terms to see what its second name is. Remember, terms are identified by the separation between them through the addition or subtraction. So I have 1 term, 2 terms, 3 terms, 4 terms, 5 terms. Now anytime that it's more than 3, we call it a polynomial. So this polynomial's name is a quartic polynomial because it has a degree of 4 and it has 5 terms. Now we need to go ahead and graph it in order to identify the number of x-intercepts it has and also to match it to a graph on this worksheet. So we're going to go ahead and grab our calculator out, and you're going to go to y equals, and you are going to enter in this equation right here. So we're going to hit x, and then we have to make an exponent of 4, and then minus 5x, and then an exponent of 3, plus 5x squared, plus 5x, and then minus 6. Once we have our polynomial entered into y equals, we now hit graph, and we look at the graph. When we look at the graph, we can then match it to the graph that we have on our worksheet. So if I look at my graph, it goes down, comes back up, goes down, comes back up again. So the one graph that it matches with is this B. Because if I look at answer choice B here, it goes down, comes back up, goes down, comes back up again. Now we can count the number of x-intercepts that it has. Well, remember, whenever it has an x-intercept, that's how many times it crosses the x-axis. Well, I can see that it crosses the x-axis right here, 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 and here. So if I count, it crosses 1, 2, 3, 4 times. So this has 4 x-intercepts. So let's practice again with another one. So if we take a look at this one, same thing that we want to do. First thing we want to do is we want to identify the number of degrees it has, and then give it a name, and then graph it and find the number of x-intercepts. Well, this is f of x equals 1/2 x plus 5. Well, because it has a degree of an implied 1 right here, then that means that it ends up being a degree of 1. It ends up being a degree of 1. Now, what we say whenever we name it is, since it's a degree of 1, we call it a linear, and then we count the number of terms that it has to give it its second name. So since it has 1 term here and 2 terms here, 2 terms is called a binomial. So we would call this polynomial right here a linear binomial. Now we're going to go ahead and graph it in our calculator, and we're going to see how many x-intercepts it is and what graph it matches with on my paper. So I go to y equals, and I'm going to enter in my equation. So I'm going to enter in 1/2. Remember, 1/2 is entered in just like a fraction. So it's 1/2 x and then plus 5. And we look at our graph. Now, if we look at our graph, it does look like a linear. We match it with the one on our paper, and the one that matches on our paper is letter A. Now we count the number of intercepts. Now this is where you have to be careful. Even though letter A matches it, see how letter A isn't really a big window? But see how if I look at my calculator, it is a big window? It will eventually touch the x-axis right down here. So even though I don't see it, this right here will eventually touch. It will eventually touch the x-axis, and it will eventually touch the x-axis at one location, one time. And again, if I look at my graphing calculator, I can actually see that on the graphing calculator. Even though I don't see it on the screen that I have on this paper, we will see it eventually touch. So let's try another problem. So if I take a look at number 3, I have f of x equals negative 2x squared minus 6x plus 8. Again, first thing I want to do is I want to identify the degree, and then I want to give it a name. Well, since it has a degree of 2 right here, we would say that it has a degree of 2. Anytime it's a degree of 2, we call it a quadratic. And then we have to count the number of terms to be able to figure out what the second name is. Well, since it has 1, 2, 3 terms right here, 3 terms we call a trinomial. So this polynomial's name would be considered a quadratic trinomial. Now we need to graph it in order to determine the x-intercepts and which graph it matches with. So I go to y equals, and I enter in my polynomial. So I would have a negative 2x squared minus 6x plus 8. And then I would push graph. And then I want to identify the graph that matches. Well, if I look at this goes up, comes back down. So the graph that matches, that goes up and comes back down again, is this letter C. So now I just have to identify how many intercepts it has. Well, if I look, it has 1 intercept right here and 1 intercept right here, which means it touches the x-axis 2 times. So this quadratic trinomial would have 2 x-intercepts, and it would match this graph right here. I want you to try the next one all on your own. So right now, if we take a look, we should have identified the fact that it has a degree of 2, and we call this a quadratic trinomial because, again, a degree of 2 is a quadratic. It has 1, 2, 3 terms, so it is considered a trinomial. We enter our equation into the calculator into y equals, and then we look at the graph. We match the graph that goes with the option on our paper. We see that the graph goes down, comes back up, so it matches graph D. We count the number of x-intercepts that it has, and it has 1, 2 x-intercepts. So we would say 2 x-intercepts. Try the next one. So if we look at this one, we should identify the fact that it has a degree of 3. So we name this a cubic, and because it has 1, 2, 3, 4 terms, we call this a polynomial. So this would be considered a cubic polynomial. We need to now graph it, so we enter our equation into y equals, we hit graph, and we are going to match the graph that goes with my equation. We see that it goes up, goes down really far, and goes up again. So the matching graph would be letter E. We then need to identify the number of x-intercepts, and we see that it has 1, 2, 3 x-intercepts because it crosses the x-axis 3 times. Try the last one. And on this one, we should identify that it has a degree of 3. So we would call it a cubic. It has 1, 2 terms, so we would call it a cubic binomial. We enter this into our y equals, into our calculator. We look at our graph to see which one matches. We see that it goes down, goes sideways, and goes down again. So it matches my letter choice F on my paper. Now we count the number of x-intercepts that it has, and we see that it only touches the x-axis 1 time right here. So it has 1 x-intercept. Lastly, I want to go ahead and talk about these possibilities right here. So if I'm looking at a quadratic or a cubic, I want to identify all of the number of possibilities, and then I want to go ahead and sketch what these might look like. Now, a quadratic, remember, a quadratic is an exponent of 2, and it ends up having the possibility of 2, 1, or 0 x-intercepts. We've already seen 2 on this paper. We're going to go ahead and draw a sketch for what it looks like whenever it has 1 x-intercept and when it has 0 x-intercepts. Whenever it has 1 x-intercept, that means that the hump or the vertex of the quadratic is going to be on the x-axis. So I could draw it looking like this, where it ends up just touching the x-axis at one location. I could also have no x-intercepts or 0 x-intercepts. That means that your quadratic would never, ever, ever touch. So an example of that could be something that looks like this. It starts at the bottom, continues at the bottom, and it never touches the x-axis. Now a cubic, the possibilities of a cubic is it could have 3 x-intercepts, it could have 2 x-intercepts, or it could have 1 x-intercept. We've already looked at an example of 3 x-intercepts and 1 x-intercept, but we're just going to go ahead and review those a little bit more. And then we're going to get the 2 x-intercept drawing. So for the cubic, if I had 1 x-intercept, that means that it is only going to cross the x-axis at one location. Now, all cubics are going to have some sort of curve to it, but it is going to continue going up. So right here, this would be an example of where it would touch the x-axis or have 1 x-intercept. For it to have 2 x-intercepts, it's going to have a bump in it. So it's going to have to go up and then come down a little bit and then touch the x-axis on that bump. It's not going to go all the way through. It's only going to touch the x-axis one location on that bump. So we can see that this would be an example of where it would touch at 2 locations on my x-intercepts. It doesn't go all the way through right here, but it does have a bump.